This tutorial looks at industrial chemistry and how industrial chemicals, with a focus on ammonia initially, can be made as cheaply as possible. The kind of factors we'll be looking at are the pressure and the temperature and the use of a catalyst, but also we'll be looking at automation and recycling some of the raw materials to make things as cheaply as possible. Imagining that you were making ammonia for a living, you've got to consider your costs. Your one-off costs will be the factory and the equipment within it and the cost of that equipment, and also the catalyst, which I guess can be used again and again. You'll also have daily costs, buying in your raw materials of nitrogen and hydrogen, your energy costs to maintain the high temperatures and high pressures for the process, and paying the workforce, in other words the wages bill. As a scientist and a businessman or woman, you've got to consider how you would reduce those costs to a minimum. Looking at the Haber process as our example, the cost of the plant is a massive one-off cost. However, maintaining a higher pressure would make a very expensive set of equipment, and therefore keeping the pressure to a more reasonable 200 atmospheres is good financial sense. To reduce the labour cost or the wages bill, automation is used as far as possible. We need to maintain high temperatures and pressures, but the higher they are, the more the bills will be, and therefore the more expensive the ammonia will be. So optimum temperature is used, which gives a good yield and also gives a very fast rate. Raw materials in this process, the nitrogen and the hydrogen, are relatively low. The catalyst is a one-off cost, so these are quite reasonable. But in order to reduce waste, as much as possible of the unreacted gases are recycled to save money. Overall, the price of product is related to how much you make by the end of the day. And in this process, it's better to have a low yield with a high rate of production rather than a high yield but a slow reaction. Looking at the Haber process, but generalizing for all sorts of other industrial chemicals, maintaining high temperatures and pressures is rather expensive, so wherever possible a catalyst is used to reduce the costs and increase the rate of reaction. Also, any unreacted starting materials are recycled to cut costs, and as much automation is used as possible. Now, it's important to have a high enough reaction rate, but it's also important to have a fairly high percentage yield of product. However, the most important thing is to have a balance between the two in order to give the best overall daily yield. So it's acceptable to have a low percentage yield of product so long as the rate of reaction is fast enough and any materials can be recycled, because it's the overall cost per unit which is most important. Here's a past paper question. This question is about the manufacture of chemicals. Many millions of tons of ammonia are manufactured each year in the United Kingdom. Ammonia is made by the reaction of nitrogen and hydrogen in a continuous process. The conditions used in this reaction are 450 degrees, a high pressure and an ion catalyst. Explain why these conditions are chosen. Use ideas about rate of reaction and percentage yield in your answer. Now, a catalyst is used because it increases the rate. A high pressure increases the yield of the reaction. A compromise temperature of 450 degrees ensures the yield is not too low, whilst maintaining a high enough rate. And here's the mark scheme for that question. And if you want to look at it in more detail, just hit pause. This second question is not about ammonia, it's about another industrial chemical, ethanoic acid, and it says it's an important industrial chemical. Large amounts are needed every day. There's a flow chart that shows how the ethanoic acid is manufactured. The first thing it asks is to write down the word equation for the manufacture of ethanoic acid. So on the left we can see what the raw materials are. They are methanol and carbon monoxide. And on the right hand side is the product ethanoic acid. The second part of the question says suggest 2 ways in which the cost of manufacturing ethanoic acid is reduced. Use the flow chart to help. Well, you can see that the reactants are recycled, which will save money. So we will say recycling the reactants. And a second thing is that a catalyst is used and it's recycled. So a catalyst would increase the rate of reaction. And it's recycled. And here are the acceptable answers, so if you want to pause, please do to read it in more detail. Sometimes, like in that last question, you have to interpret data in a table, but sometimes you have to interpret data in a graphical form. They'll give you a graph of the yield of a reaction and how it's affected by the temperature and the pressure, so we must be prepared for this. You also need to know a little bit about the importance of ammonia. Why on earth is ammonia made by the Haber process and what's it used for? This question is about nitric acid. It's made from ammonia. The first reaction in the process involves the oxidation of ammonia. So ammonia and oxygen makes nitrogen 2 oxide and water. There's a sketch graph which shows the percentage yield of nitrogen 2 oxide at different temperatures and also at different pressures. The first question says, how does increasing the temperature change the percentage yield? We have the percentage yield on the left-hand side of the graph, and if we look at increasing the temperature, we can see that as we go from 600 to 1000 degrees, the percentage yield of nitrogen oxide reduces. So the answer is, how does increasing the temperature change the percentage yield? It decreases. The second question says, how does increasing the pressure change the percentage yield? For this we need to look at one particular line, keeping the temperature the same. Here we can see that as we increase the pressure in atmospheres, the percentage of nitrogen oxide decreases. So it decreases. A low pressure of 10 atmospheres and a high temperature of 950 degrees Celsius are used for the production of nitrogen oxide. Suggest why? Well, a low pressure of 10 atmospheres will give a high percentage yield. However, if we look at the temperature, it's going to give us a low yield. So why is a high temperature used? That's because it gives a high rate of reaction. So what's the importance of ammonia? Well, as we saw in one of these previous questions, ammonia can be used to make other industrial chemicals, and one of these is nitric acid. Nitric acid's an acid and ammonia is a base. When these are reacted together in the right proportions, they make a salt called ammonium nitrate, which can be made into crystals, and these crystals are sold as a fertilizer because they contain nitrogen atoms which can be used by plants for growth. So ammonium nitrate is a fertilizer. Fertilizers are very important in world food production.